Good morning everyone. Today we are going to see about the most important searching algorithm in computer science and artificial intelligence, the A-star search algorithm. How the A-star search algorithm is more special than the other searching algorithms? It's nothing but A-star search algorithm uses it can be calculated to find the particular solution. We use the actual cost and then the the guess, which how many steps we are ahead of reaching the solution. So in this way it is more special and different from the traditional searching algorithms. So let us go dive into this topic. So why it is a powerful pathfinding algorithm? In the field of computer science and robotics, for finding the most efficient path, the A-star search is very important, playing a better role in finding the most efficient path. And its optimality and completeness makes it more reliable for solving a more complex problems. And when the heuristics is nothing but the additional information is more efficient, we can easily find the solution, which is nothing but the the path methods. So here when you are going to see about the nodes means the different states or the locations, and you can consider here the A, B and C, D or the nodes, which is nothing but the states or locations in the searching the path. So here we consider the start node as A, and we have to find the goal node, which is nothing but D. Here B and C are the intermediate nodes. So the distance between the two nodes, for example when we are considering the node A and node B, the distance between them is 5 units, and the distance between the node A and node C is 4 units. Within the A we can see, within the circle we can see A9. The 9 is nothing but the heuristic value, which is nothing but the guess that we have to use that guess value to check that whether we are very near to the goal state or not. So defining the heuristic value plays a huge role in finding the efficient path. First condition, the heuristic value should be more admissible. Here it tells that we have to choose the heuristic value, but it should not overestimate the actual path that we are from the starting node to the goal state. And then the consistent heuristic. Then here the consistent heuristic can be satisfied by a formula. This is a triangle inequality. The cost from the goal A to the goal. Here A is the starting node and D is the goal node. The distance between this should be less than or equal to let's separate this into a two parts, from A to an intermediate path B, and then the cost from the B, that intermediate part, to the goal state. The actual distance between the starting node to the goal node should be less than or equal to this goal A to the intermediate goal, and then the intermediate node to the goal state. So if the heuristic value is inadmissible, we cannot find the efficient path, it will be a vain. So the explanation of the A-star algorithm. Here we are using a formula, Fn is equal to Gn plus Hn. Here Fn is the total cost, which is equal to the actual cost, which is nothing but G of n. That means the starting node to the node n, and the heuristic, that the special guess that we are going to use this to find whether we have reached the goal state or not. And then open and closed sets. Here the closed set means that the nodes which we have already visited. The open set is the nodes which we are going to visit now. And what was the purpose of using this A-star algorithm? Means we can easily find which path is low and efficient to reach the goal state in a short span of manner. And the step-by-step explanation of the A-star algorithm is first initialization. First we have to start with the node. Then this node, it will be in the open set, that the node which we have to be visit in the future purpose. And the node expansion, we have to select the lowest Fn. Fn means the sum of G of n, the actual cost and then the heuristic value. We have to select which nodes f of n is very low. Then we have to add that to our closed set, and then we have to repeat this process in a greedy search algorithm manner to reach the path in an efficient manner. Examples. So here we consider that the node A is a starting point with the actual cost 9. Here we get that the g of n, the heuristic value is 0 and the h is equal to 9. Totally f is equal to 9. Then the first expansion, we are going to the node B or C. We have to choose whether we have to go to node B or node C. Here node C is chosen for the expansion because when we are considering the node B, we are having the f value is equal to 9, which is greater than the total actual cost of reaching the goal state when we are reaching through the node C. So we are considering the first expansion from the node A to node C, and then from the node C we can easily reach the node D, which is nothing but the goal state with the cost of 9. So comparing the node B, when we start from the node A to the node C, then reaching the goal state is in a efficient manner when comparing it to the node B. So CD is very optimal. ACD, the path is very optimal in comparing to the path ABD. So what are the practical applications of A-star search algorithm? In a real-time environment, we are using this algorithm in GPS navigation and logistics. In GPS navigation, we will be used in the Google Maps for considering which is the shortest path to reach the destination. And in game AI, we will be using the gameplay and strategy to reach the particular destination in a very short span of manner. In robotics, the robotics in the complex environment use this A-star search algorithm to reach their destination in a short manner. And what are the significance and optimality of A-star search? Optimality guarantee. Here, when the heuristic value is admissible, we can easily find the least cost path, which is more efficient to find the path between the start node and the goal node, and efficient gains. So we have to focus on the heuristic and ensure that whether the heuristic is admissible for getting the efficient path, so it will be gaining some efficiency. Next, wide adaptability. So due to the efficiency of the heuristic, we can efficiently find the shortest least cost path. So it is widely adapted by many graphs and heuristic in our real-time environment. So its applications are benefiting our industries for improving the planning and lower cost and smarter systems. Conclusion. Effective search algorithm. So the A-star search algorithm is providing a powerful and flexible for finding the path with using of the heuristic. The critical roles of heuristic means we have to carefully design the value of heuristic, so it will be ensuring the efficiency and the solution, the quality of the solution, it will be ensured by this heuristic. So we have to ensure whether the heuristic is admissible or not to find the efficient path. Thank you.